Once we've achieved a level of confidence with the basics of Java, that being both the Java syntax and the basic object-oriented concepts that Java was built around, it's time for us to take a look at Java's API, the class libraries immediately and easily accessible to us when we're writing Java programs. We want to do this for a couple of reasons. First, we're going to be using these class libraries to speed up our programming and to make use of the work of programmers who have written really great stuff. If something's put in the Java API, for the most part, we can be reasonably sure that this is the best and most efficient way Java has to complete the individual task this class library is designed to do. Taking a look at the Java class libraries, or the class libraries of any programming language really, is also a great way to see how the programming language is designed to use, and what optimal coding in that language should look and feel like. Today, we're going to take a look at Java's calendar class. When writing Java code, we generally use the calendar class to refer to a specific moment in time. The calendar class is actually a relatively new addition to the Java API. Previously, we generally used a class called date to perform similar functionality. If you end up working on older Java code or are writing Java code that's dealing with a SQL or MySQL database, you'll probably end up using the Java date class at least occasionally. If this happens, don't panic. Consult the Java documentation and you'll discover that there's some really great functions for swapping between calendar and date objects. To see the power of Java's calendar class, let's jump into a Java program and instantiate one. I've gone ahead and created a new program and imported java.util because that's where the calendar class lives. And I'm going to declare a new calendar object, and I'm going to call it now because our first goal is to assign the value of this calendar object to be the current moment in time. While we haven't actually looked it up in the documentation, this seems like a reasonable starting or default date for a calendar instance. So let's set up our program so that we can print out the information contained in our now object. And let's just assign the value of now to be the default value of a calendar object and see what that gives us. To do that, I suppose we're going to need to create a new calendar. Perhaps surprisingly, this basic program actually fails when we attempt to compile it. Here's our error on line 7. The error is calendar is abstract and cannot be instantiated. If you'll recall, abstract classes are those that are designed purely to be subclassed, and we can never declare an instance of an abstract class all by itself. So, what good is Java's calendar class if we can never create one? Of course, that's not a fair question, because we definitely can create calendar objects. They just have to be a specific type of calendar. We're almost always going to make use of the Gregorian calendar. But let's take a step back and assume, perhaps rightfully so, that we didn't know what calendar options were available to us. This is one of the times when working with an IDE, an integrated development environment like NetBeans here, can be really amazing. Normally at this point in time, we'd have to take a trip to the Java documentation to see exactly what subclasses of calendar are available for us to instantiate. But because our IDE knows some metadata about the packages that we've already imported, we can ask our IDE what it thinks might be a possible solution for this place in our code. If you're working in NetBeans, you can get these kind of suggestions very often by checking some of the code completion blocks. But to keep code completion from popping up all the time and making these videos pretty much unwatchable, I'm going to make use of a NetBeans shortcut on occasion. This shortcut by default is the key combination Control Space, which will prompt a code completion pop-up window for the current location of our cursor. Code completion in NetBeans is excellent. NetBeans has given us 3 possible suggestions. Here's the abstract calendar class, which we already know we don't want to use because we can't actually instantiate an abstract class. But Buddhist calendar and Gregorian calendar certainly look like subclasses of calendar. If we select Gregorian calendar, we'll see, in fact, that it is a subclass of calendar. So let's go ahead and attempt to create a brand new Gregorian calendar at its default settings and values. If we run this Java program, we do, in fact, get some output. That means, 1, our syntax is okay because we compiled successfully. And 2, we can see what values Java puts in a brand new calendar object. One of the great things about Java is how extensive and demanding it is that new objects implement the toString method used by println. This means that most Java standard library objects are capable of printing themselves out in some sort of human-readable format when we ask them to. Our new calendar printed out here isn't exactly easy to read, but we can go through it and see that values have been assigned to many of its fields, and we can also see what the fields that a calendar has actually are. But let's see about getting just one piece of information from the calendar. Let's see if it is actually set to the value of today. Let's check the day, month, and year. To keep things simple, we'll just do this on 3 separate lines. And now we're going to need to get those fields from our calendar object. If our calendar represents a specific moment in time, it should have fields for day, month, and year, right? Well, if we open up our autocomplete, we can take a look at all the fields and methods available to us exposed by our calendar object. We're not actually going to find an easily accessible day, month, and year field. And this might start to disenfranchise us with calendar. But in fact, we're just not going enough levels deep. Calendar exposes the get method. And get allows us to acquire these fields that describe the specific calendar instance or moment in time. It's a function that takes an integer as a parameter. To some of us, this might look a little confusing at first. Why would we provide get with an integer to tell it what calendar field we're looking for? This integer is actually an enumerator, which we'll think about for now as a static string exposed by the calendar class itself. If we type in the calendar class name, like we wanted to get a static member variable and then go back to autocomplete, we see a list of options that we can utilize in this instance. Some of these options don't make a lot of sense. We have to remember that autocomplete is just telling us what calendar exposes. It's not giving us the solution because it has no idea what we're trying to do. For example, we wouldn't want to use our calendar instance to get its value of May. That wouldn't make any sense. But we can use our calendar instance to get the current month. Similarly, what we really want is day of the month and the current year. If I run this program, we get the output 7/20/2013. I'm recording this video on August 20th, 2013. So this is actually a little confusing because August is the 8th month of the year. Fortunately, there's a reasonable explanation for this. Unlike day of the year and year, which makes sense to store as integer variables, most implementations of calendar and calendar-like classes in most programming languages, not just Java, choose to store months as an array because in addition to a numeric value, each month also has a corresponding string, its name. Since arrays are zero indexed, our month appears, if we forget about this, to be 1 month lower than it should be. Our printline function should probably look like month plus 1. And that, you'll have to trust me on this, is today's date. So calendar has a whole lot of methods associated with it. In addition to just setting a calendar to the current point of time and reading from it with our get function, we can set calendar to points in time using the set function. We can add or subtract using negative values to point in time using the add function. And we can see if points in time are before or after other points of time using the before and after functions. If you're like me though, you'd like to know a little bit about how this calendar is really operating. Is it storing the month, day, and seconds of time in separate fields, or is there one big number that contains all of this information? If we spend some time and take a look at the methods available to us in the calendar implementation, we'll find these two methods, set time in milliseconds and its sister method, get time in milliseconds. The fact that these methods are specially set aside is a really great window, an opportunity for us to see how the calendar class really thinks. Let's begin our exploration by calling this get time in milliseconds function and printing out its output. We get a really large integer number, which is presumably the time in milliseconds since some particular point in time. If we were to do the math on this though, we would discover that this point in time is not actually the year 0. Rather, it's a time much closer than that. This point in time is referred to by the calendar class as the epoch. And it's the point in time which we start counting from when we store a time in Java in terms of how many milliseconds it's been since the epoch. Now, we could whip out our calculator and, through a pretty painstaking process, figure out exactly what this point in time was. Or we could do it in our native Java environment with a lot less pain. Let's simply change the value of our now, originally set to the default or current moment in time, to be the time when milliseconds is set to 0. We'll do this with set time in milliseconds and provide 0. When we run our program again, we get the same output fields. Here's our confirmation that milliseconds has been set to 0. And now our calendar moment in time is December 31st, 1969. So once we start adding days to our object, we'll be counting from January 1st, 1970. This point in time is referred to by the Java calendar as the epoch. So, why is this a really interesting thing for us to know? It means that we can convert our calendars to these millisecond values and then add, subtract, and I guess multiply and divide them as integer values. This allows us to use all sorts of operations on them in the native format of mathematics. Before we go, I'd like to show you one more thing, because it's a bit of syntax that you may not be familiar with and may not immediately recognize when you come across it. If you'll recall at the beginning of this video, calendar is an abstract class. We can only instantiate specific types of calendars. However, oftentimes, we won't specify exactly what type of calendar we're looking for. We'll ask the calendar class to decide for ourselves. As we saw with our enums here, the calendar class, in addition to having object level methods, does provide some static methods that we use just by referencing the calendar type name. One of these methods is calendar.getInstance, which will create for us the best fit calendar that Java can figure out. In this case, it's going to be that same Gregorian calendar that we were creating already, and we'll see the earlier output. Thanks so much for watching.